Hey everybody, it's Mr. Carr again. Today we're going to be starting up our new unit, Unit 3 here. The first day we're going to be talking about is properties of our exponents. And so when we talk about our properties, we want to look at a variety of rules. First thing, just to talk about real quick vocab. If I talk about the base, I'm referring to this value. When I refer to the exponent, I'm talking about this one. So what does it mean when we have an exponent like this? It means repeated multiplication. 2 to the 8th power is the same as 2 times 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 2. 1, 2, 3, 4, 5, 6, 7, 8 of them multiplied together. Okay, so this is helpful for each of our little rules here. Yeah, that's good right there. Okay, so the product rule is that if we have 2 to the third and 2 to the fifth, we basically have 3 2s and 5 2s being multiplied together. Well, that's going to look like this right here. If I split it up, here's 3 and here's 5. So that's going to give me 2 to the 8th. The shortcut is we just take the 3 and the 5, we add them together. So the idea is this: I have a to the n times a to the m power. That equals a to the n plus m power. We are going to add our exponents together as long as we're multiplying with the same base. With division, it works kind of the same. It's going to work the same way, but backwards. 10 to the 7th, there's 10 sevens here. So I can do 10 times 10 times 10 times 10, 1, 2, 3, 4, 5, 6, 7. Underneath, there's just 3 of them. So what happens here is I cancel out here, here, and here, and I'm left with 10 to the 4th power. There's 4 of them left. The shortcut is we just subtract 7 minus 3. Okay, if I did 7 minus 3, that would have gotten me 4 as well. So that means that if I have a to the n over a to the m, that is equal to a to the n minus m. When I do a power of powers rule, we raise this there. We have 7 squared 10 times. So we have like basically 2, 4, 6, a bunch of them. What this turns into is 7 to the 20th power. We are just going to multiply these together. So that's a to the n raised to the m power is the same as a to the n times m. Power of products, if I have multiple things inside, everything inside is going to be raised to that power. So for example, here, this would be 3 to the third, m to the third. So that means as a rule, it would be like this. If I say ab to the m power, that's a to the m, b to the m. Power of quotients works the same way. Everything inside is raised to the second power. So it's 7 squared over x squared here. So if I have a over b to the m power, that's the same as a to the m over b to the m. Anything to the 0 power is just 1. So that's just my rule there. A to the 0 is 1. Finally, negative exponents. A negative exponent is the same as the reciprocal. So 1 over 3 squared. So if I ever have a to the negative n, that's the same as 1 over a to the n. Additionally, kind of off that idea too, that's the equivalent of saying if I have 1 over a to the negative n, that's the same as a to the n. So I just flip that to the numerator. So technically I'm putting that over 1 there. These are our exponent rules. So for today, we're just going to work through and do a variety of examples, but we're just simplifying with that. Okay, so when we look at this one, first thing I like to do is I like to take care of my negative exponents and just flip them right away. So that this is going to turn to negative 2 to the 4th power over negative 2 to the 8th power. Instead of multiplying that out and actually doing that as exponents, I'm going to go ahead and do my next rule, which is subtraction. 4 minus 8, or yeah, I could do 4 minus 8. I could always do my numerator minus my denominator. But additionally, I could always just do the larger one minus the smaller one. So what this turns into is 1 over negative 2 to the 4th power. So that's what I'm really doing is, let me write it down this way, 8 minus 4 that way. So I always leave it as the bigger one, wherever that goes. I do that subtracted by the smaller one. So that's negative 2 to the 4th power. Since it's a negative value raised to the positive 4 like that, or raised to an even number, it's going to be the same as doing 1 over 2 to the 4th. You can probably just leave it like that, but if you want to multiply that out, you can. 2 to the 4th power is 16, so that's 1 over 16 here. For the next one, 2 to the 4th raised to the 3rd power. The rule says to multiply these exponents, so that's 2 to the 12th power. And that's a big one, so I'm going to leave it alone. Here, I like to work on what's inside parentheses first. It's easier if I simplify that. So that means if I do this 3 to the fifth, 3 to the third, that's the same as 3 to the, yeah, let me write it this way, 3 to the 5 minus 3 power, and that's raised to the second. So that's going to be 3 to the second power to the second power again, which is 3 to the fourth power. And I'll just leave it like that. Back up here, I've got 3 squared. If I flip my negative exponents first, that'll be 3 to the second power over 3 to the seventh. Again, using my subtraction rule, I'm going to do 1 over 3 to the 7 minus 2, which is 1 over 3 to the fifth power. Excuse me. Here, remember, working it inside first, 5 to the 0 power is just going to be 1. So that's going to be 1 to the third power, which is just 1. Over here, if I take care of everything inside first, I'm going to have 4 minus 2. So 1 over 10, it'll be 4 minus this 2 here, so it'll be 10 squared, raised to the negative 2 power. Then I like to flip my fractions. With this negative 2, that's the same as 10 squared to the second power. I'm just going to flip it from 1 over 10 squared into 10 squared over 2, or 10 squared over 1 is what I'm officially doing. Raising 10 squared to the second power, I get 10 to the fourth power now. And that's it for that one. When we start throwing in some variables, I'm still applying the same rules. So I'm just looking to simplify these as best as I can. So in the first case, remember this is x to the first. So I can do this as flipping all my negatives first. That's one way to do it. So if I have x to the ninth, x to the first over x to the eighth, x squared. So those are just going to flip underneath here and here like that. So then 9 plus 1 is going to give me x to the 10th power. 8 plus 2 gives me x to the 10th power. And that just ends up being 1. Over here, we'll do this one next. So if I flip, honestly, I could flip these, but I've got n to the negative fifth divided by n to the negative fifth. They're just going to simplify to 1. Then I got nothing else for m, but then I have 16 over 2. So 16 divided by 2. These are not subtraction. Just make sure we're clarifying that. That's division still. 16 divided by 2 is going to give me 8. And then I'll end up with n to the fourth. So for the next one, again, I take my negatives and I flip it to where it makes it positive like this. So now this turns into x to the fifth times x to the fifth. So that's going to be 10 times x to the 5 plus 5 over 2. 10 divided by 2 is going to give me 5. And then x is going to be raised to the 10th power. Okay, for the next one, I have to kind of work it from here, from inside parentheses out. So negative 3 and 3 to the second power is going to be x to the negative 6, and then y to the 6th over x to the 5th, y to the 6th. Okay, so basically this 2 is going to be raised to, like negative 3 and 3 both get raised to the second power here. From here, y to the 6 divided by y to the 6 actually cancel each other out. Negative exponent, I'm going to go ahead and bring it down to the bottom. So that's going to be 1 over x to the 6 times x to the 5th. And then I could add these exponents together. So 6 plus 5 gives me 1 over x to the 11th. All right, our last round of examples here, just some more tricky ones, that's all. So here, everything here gets raised to the negative third power. There we go. Raised to that negative third power. So that's going to be 3 times negative 3, so it's be a to the negative 9th. Negative 4 times the negative 3 is b to the positive 12 now. And if I don't want to, so one rule that to make sure it's clear, never leave it as negative exponents. Okay, so make sure that's clear. No negative exponents. You're always going to make sure that you turn positive. So that means my final answer here is b to the 12th over a to the 9th power. Next one almost looks like we're raising powers to powers, but they're actually all multiplication. So for example, I can write it as a to the negative 1st times a to the 8th times b to the negative 9th times b to the negative 9th. I'm going to flip all my negative exponents now. So I only have a to the 8th in my numerator. I'll have a to the negative, or a to the 1st down here, b to the 9th, and b to the 9th. From here, I can apply my subtraction rule for a. So we got 8 minus 1 is going to give me a to the 7th. 9 plus 9 gives me b to the 18th. For the next one, everything here gets raised to the second power. So I'm going to have 5x squared, y to the negative third. times negative 2 to the second power, which I'm going to go ahead and just make that a positive 4. X negative 1 and 2 is going to make it x to the negative 2 power. 3 and 2 is going to make it y to the 6th. Now I like to flip all my negative exponents here. So that's going to be 5x squared times 4y to the 6th all over x squared y to the 3rd. X squareds are going to cancel each other out. I'm going to do my subtraction rule here, and I'm going to go ahead and multiply 5 times 4 to give me 20. And then 6 minus 3 gives me y to the 3rd. Next one just looks a little more complicated, but go through and just take it step by step. First thing is x to the negative 2 and x to the negative 2. They'll cancel each other out, so I don't have to do anything else with that. Okay, my negative 4 will flip to the top. My negative 1 will flip to the top. So I'm going to have y to the 4th. Whoa, hello. Let's try that again. Y to the 4th times another y to the 4th times 3x cubed times y to the 1st. All that's left in my denominator is 2 times 6. Okay, from here I've got 4, 4, and 1. So I'm going to add those together to make it 8 plus 1 is 9. So it'll be y to the 9th power. 3, this 3 here and this 6 can kind of reduce. If I divide by 3, that's a 1. Divide by 3 is a 2. So I can just do that right now. And then I also have x to the 3rd. And then now my denominator is going to be 2 times 2 is 4. So my simplified answer is x cubed y to the 9th all over 4 here. Just, I like to work off of taking care of those negative fractions first. Always work from inside parentheses out. That'll be easier way to keep track of everything. But that's it for our first day with our exponent properties. All right. So again, we got these 1, 2, 3, 4, 5, 6, 7 properties. You're just looking at them in a variety of ways, depending on both numbers and variables. That's it for today. Take care, everyone.